So I wanted to set a little background for this talk. So picosecond lasers have been around maybe around 10 years now, and they've kind of been the rage, and they've taken things over in terms of dermatology with skin rejuvenation. But we also have nanosecond lasers, which have been around for much longer. These devices are much more reliable, they're much more cheaper, and they can do many of the things that we do with picosecond lasers fairly well. One of the interesting things that we saw with picosecond lasers, though, is when you put a fractional optic on the handpiece, you get these unique tissue injuries that were coined LIOB, laser-induced optical breakdown, and these were thought to bring about low downtime, kind of rejuvenating procedures of the skin. And so we had a Q-switched or nanosecond device that we've had around for a long time, and we wanted to see what if we put some sort of fractional optic on this handpiece, like what kind of injuries would we get on the skin and what kind of effects would those have, right? And so this is the device we used. It's a 532-1064 Q-switch. The pulse duration is about 5 nanoseconds. So it's not all that different than some of the picosecond devices that are, 500 or 750 picoseconds long. It's not, much more than one order of magnitude different in pulse duration. And then we use something called an MDF, multi-depth focus microbeam handpiece. And basically this kind of fractionates the laser beam. And you can see in that little illustration, these LIOBs, they're almost like little tears or kind of holes when you look at the skin under histology. And they're thought to bring about these changes in collagen stimulation and skin rejuvenation with very minimal downtime. So, this was the first time this was being used on something that wasn't a picosecond device. So we did a kind of very small focused study. And the first thing we did was we just tested doses, and we escalated by 0.05 joules per centimeter squared all the way up to 1 joule in terms of fluence, with 5 pulses delivered one after the other. And we did this at 3 different step depths for the handpiece, the MDF handpiece. And then we just looked and evaluated the tissue response and side effects. And then the next thing we did was we took the optimal settings from test 1, and then used 3 subjects, and then we actually obtained tissue biopsies, and then we looked at the reaction under the microscope. So this is some of the tissue reaction that you can see, and this was done with the 532 nanometer wavelength about 2 to 3 hours afterwards. So you can see that this does actually induce a pretty significant skin response to the skin. The discomfort was actually fairly low, so the pain scores on average were about 3 out of 10, which kind of falls in the mild range. There was a little bit of erythema seen, but you could get all the way up to pinpoint bleeding when you go up to the higher doses. We did see hyperpigmentation in these subjects across all 3 depth settings, and the hyperpigmentation resolved without any sort of intervention or post-topical treatment within 45 days. The higher the fluence, obviously, the longer the downtime. And so we set upon a clinical setting of step 2 using the 532 nanometer wavelength, and then starting all the way kind of at 0.04 and then escalating up to 0.2 joules per centimeter squared. And here you can just see kind of some of those tissue reactions again. And then this is where we got the histology. And so what you can see under the microscope is these kind of like vacuoles or little tears that are indicated by the arrows. This again was done with a nanosecond laser, and these injury patterns are very similar to what you kind of see with the picosecond devices, except these are a little bit smaller, and this is a different wavelength. This is the 532. Classically, this was done with the 755 nanometer handpiece. So in conclusion, this evaluation gave us a better understanding of a mostly unused wavelength and a longer pulse duration with nanosecond lasers. So we were able to identify some optimal clinical settings, but the clinical use and application of this we're still figuring out. But the interesting thing is, we talk about these picosecond devices. They're 2 to 3 times the cost of these nanosecond devices. They require a maintenance contract, which is very expensive, whereas these nanosecond devices barely break down, right? So when you're a practicing clinician like I am, just looking at cost, it's a big concern. Thank you so much.
Great, thank you very much, and thank you to the speakers for staying on time. So we have a break built into the schedule here, and since we're on time, we could use this opportunity to take questions for the 2 speakers who are up at the panel. Our 3rd speaker had to go to another session, so we'll please come on up to the microphone, or if there's any questions, we'll take those now.
Chris Zachary, UCI. I'm disappointed that Omar couldn't stay for question time, because I think traditional technology reused in a different way it's so important. I'm really impressed with him doing this. I wonder why we didn't do it before, honestly. One of the things I wanted to ask him was the pigmentation that he got subsequent to treatment, whether that was just melanin or whether it was hemosiderin, because of a little bit of bleeding that he got. But anyway, I do think that we should use our abilities to apply new knowledge to old technology, and with that save clinicians a lot of money, etc. Because I totally agree with him that the nanoseconds, I still think are very good. Our nanosecond device is 20 years old. We still use it. Thank you.
Thank you. So, Dipti, I did have a question for you. So the in vitro experiments that you did, could you give us an idea of how many times you tried those? And I didn't see any statistical analyses. I don't know if I missed that. So did you check to see if any of those were significant from each other?
Yeah, so we did try the experiment multiple times because, again, it was a scratch experiment. We had to optimize it so that even the scratch was right enough and the width of the scratch was right enough, so we had to keep that consistent. From what I also know, my team did it, we all did it together. Mm-hmm. From what I know, the experiment was done at least 7 to 8 times for each study one as well as study 2. And again, after talking with Dr. Rani, we did find the experiment was significant.
Thank you. Any other questions? Okay. 2-minute break, yeah. So we, in the interest of keeping us on schedule, we'll start our next talk at 1:52 as shown on the schedule. So we'll have a couple minutes before we start the next one.